So this is a video for homework 2. This is 8.1.29. I believe it's problem 13 of this problem set. And what can be difficult about this one is that it's a long problem. So we're just going to go through each piece here. One thing that I definitely like within the question help for this one is the view and example. If you click question help, you can go to view and example, and especially for that first piece where they're asking, do you think the variable of time spent watching TV is normally distributed? It has a great explanation here. So one thing that they kind of go over is the shape of a normal curve, and a continuous normal random variable that is normally distributed would look like this. Now the only thing about time for spending TV, and they're kind of explaining it here, is that of course somebody could watch no TV, but then you have a very large upper bound. It kind of continues on forever. Well, not forever if we're talking weekly, but 24 hours a day, 7 days a week, watching a ton of TV. So we don't know what those upper bounds could be. So they're saying it's likely not normal. Now, if you think about this continuing kind of on and on and on and on, and not knowing where it's going to end necessarily and how many people are going to be watching lots of TV, this could be very right skewed. So the correct answer here is that it's likely skewed right and not normally distributed. And again, you can read through that explanation. It's really a good explanation there of why they think that it's right skewed. Now for part B, it says, according to a certain survey, adults spend 2.45 hours per day watching television on a weekday. Assume the standard deviation for time spent watching TV is 1.93 hours. They're saying if a random sample of 40 adults is obtained, describe the sampling distribution. So what you want to know about a sampling distribution is that the mean is going to be the same as the population. So that's why they're getting, okay, 2.45 hours here. That's why it's the same here, right? However, the standard deviation is going to be the population standard deviation divided by the square root of the sample. So the way that they got this, and I'm just going to go ahead and pull up my Google calculator here. The way that they got that is that they took 1.93 hours and they said, okay, now we have 40 adults, which is the sample. We're going to divide by the square root of 40. So we're going to do 1.93, 1.93 divided by the square root of 40. And you can see here we're getting 0.3051 blah, blah, blah. And they are rounding here. I think they wanted to 6 decimal places. So they got 0.305160. 0.3051, and then again, because we're rounding to 6, this 9 is in that 6th spot. The 7 is next to it, so we need to round that up. Now when you round up a 9, it also bumps the 1 next to it because you have to carry over that 1 from the 10. So that's why we're getting the 60. Now, one other thing here is that you had to choose that x bar is approximately normal. Remember that what the central limit theorem says is that as you take your sampling distribution, we do get a mean that's approximately normal. So if I keep taking samples of 40, samples of 40, samples of 40, samples of 40, your x bar is going to become approximately normal. And again, if you're not sure about that, take a look at my video from week 2 that explains the central limit theorem using bunnies and dragons. It's a great video, and it's kind of cool to actually be able to see how that would work. Okay, part C. It says, determine the probability that a random sample of 40 adults results in a mean time watching television on a weekday between 2 and 3 hours. Now this is where you could go through the question help, and it's going to show you how to calculate your z-score, and then tell you to either use technology or use the table to find your probability. But StatCrunch can do it for us, so why not let StatCrunch do it for us? We're going to go to question help, click StatCrunch. And what we're going to do is we're going to pull up our normal calculator. So you're going to go to Stat, go down to Calculators, and then go down to the normal calculator. So what I'm going to do is I'm going to adjust this normal curve to be the mean and the standard deviation that I want. So remember, I'm just going to minimize this for a second. Remember that we have, for the sample of 40, a mean of 2.45 and a standard deviation of 0.305160. So let's put that in there. So 2.45 for the mean, and then I have 0.305160. I'm just going to make sure I did that right because sometimes I copy the wrong thing. 0.305160, especially when there's that many decimal points, right? And click compute. And you can see here that we have now adjusted this normal curve. Now we want between 2 and 3 hours, so we're going to click the between calculator here, and you can put 2 and 3 and click compute. And now it gives us the probability, because the probability is going to be the area under the curve between those two scores. So I'm getting 0.894098832. Let's see what they got here. And they're only rounding to 4 decimal places, 0.8941. So 4 decimal places. Notice that 0 is in the 4th decimal place. There's a 9 next to it, so we're rounding up to 1. So we did get the correct answer. Okay, there's that one. So let part D. One consequence of the popularity of the internet is that it is thought to reduce television watching. Suppose that a random sample of 35 individuals who consider themselves to be avid internet users results in a mean time of 2.03 hours. Determine the likelihood of obtaining a sample mean of 2.03 hours or less from a population whose mean is presumed to be 2.45 hours. Now, what we have to do here is that we have 35 individuals now, so we're going to have to adjust our standard deviation. So remember, we're going to take the original standard deviation and we're going to divide by the square root of the sample size. So before we had, again, let's look back up here, 1.93 hours. So I'm going to take 1.93 and I'm going to divide, instead of the square root of 40, we're going to divide by the square root of 35. So 1.93 divided by the square root of 35, and I'm getting 0.3262295. So I'm just going to copy and paste this in here. They had said 6 decimal places, I believe. So 1, 2, 3, 4, 5, 6. This is going to round up. So I'm just going to take 7 decimal places. That should be good enough. And I'm going to go back here and I'm going to copy that in. Okay, and again, they wanted, I'm going to minimize this again, I'm sorry, I did all the clicking, but we want 2.03 hours or less. Okay, so 2.03 hours or less. So I'm going to do in my StatCrunch calculator, and now do your standard instead of between. So we're going to switch this, and see how we have the less than symbol? You could make it the greater than symbol, but we do want to keep it less than. And I want 2.03 hours, so click compute. And I'm getting 0.09897, so let's see if we got that correct. 0.09, and it says 897, so again, we're going to be rounding to 4 decimal places. So the reason they put 0.990 is because that 7 makes that 9 a 10, and then we have to actually carry that over to the 8. So just be careful with the rounding. It could really kind of mess you up here. Just be very careful with that. Okay, and that's how they got that answer there. It says interpret this probability, select the correct choice below. So one thing to look at here is that the wording is going to be very different. So each one of these, we're talking about 1,000 different random samples. So this one says a mean of exactly 2.03. Well, that's not what we found. We were talking about less than. This one says more. So we're not going to choose that. This one says less. So we're going to choose part C because it does say less. And it wants how many of the samples it's going to happen. What you're doing is you're taking 1,000 and you're multiplying by the likelihood. So if I do 0.0990 times 1,000, I will get 99.0. Now, if yours is a little bit different and you get, a decimal point, just make sure that you round, because you can't have a decimal number of samples. You have to have a whole number. So that's why I'm going to get 99 in this case. Now it says, based on the results obtained, do you think avid internet users watch less television? So we're talking about likelihood here. So remember that something that's considered unusual is if it's less than 5% of the population. We have only 99 of the 1,000 are would actually have this happen. So do I think that would actually happen? I would say no. Okay, now yours might be a little bit different than this. I've gone through this example using the problem numbers that I was given. You're going to be given different numbers. So if you have any trouble with the rounding or anything else, just please contact me and I'd be happy to help you.